So in this first instance, the first thing I'm going to do is I'm going to start a trace in my session. And I'm going to use that script that I already showed you the contents of. Pretty simple. Saved me a lot of typing there. And now I'm just going to select one row from that table that I created. One simple row. Okay? The other thing I'm going to do is I'm going to repeat those same steps over here in my other session on the other instance. Okay? Seems simple enough. Now let's go back to host 01 over here. And let's look at the session stats that were generated from the activity. Now remember, all we did here was we started a trace in the session and we selected the one row from the table. Here we can see that the session did some logical reads and it did a fair number of physical reads. And then we see some global cache transfers. We know they're global cache transfers because the statistic name starts with GC. They don't say cache fusion anywhere in there. They say global cache. And I had some blocks that were received. And there's a few small amount in there. Now let's look at the session over on host 02. Notice there that the physical reads were much less, but the number of global cache transfers were much higher. Let's go back and look at host 01. 61 physical reads and a total of 6 global cache transfers. On host 02, down to 21 physical reads and 149 total global cache transfers. Now, not all of these global cache transfers were the blocks involved in this statement. Some were due to recursive SQL. The recursive SQL, if you are not aware, are the SQL statements that Oracle issues on your behalf. For instance, when you go and you try to access a table, Oracle will issue an SQL statement to see if you have privileges on that table. That's recursive SQL. Last thing I want to do is I want to get my trace file name. Okay, so there on host 02 is the trace file name of my session. And I'll go back over here on host 01 and do the same. Okay, so I'll exit out of SQL Plus. Now I'm going to take this whole trace file name. I'm just going to use VI to look at the contents of my trace file. And then I'm going to search for that table. This is my raw trace file. And here is my SQL statement that I had executed. And we can see in here a DB file sequential read, a DB file scattered read, and a DB file sequential read, all on file 5 with a couple different block numbers. Block 515, block 516, and block 131. Okay? We can see the DB file sequential read read 1 block, then the DB file scattered read read 4 blocks, and then the DB file sequential read read 1 block. This is 3 different read requests that read into the buffer cache 6 different blocks total, all to satisfy this one SQL statement. Now remember, this was host 01. The instance had just come up. These blocks were not in the buffer cache, so they had to be read from disk. The wait events showed us here in the trace file that these were in fact physical reads from disk. Now let's go over to host 02. And we'll exit out of SQL Plus. And again, we'll use VI to look at the contents of the trace file, and I'll just fast forward to where that statement is. Notice this time there are no physical reads being performed. In its place are 3 global cache wait events. the GC current block two-way, the GCCR multi-block read request, and the GC current block two-way. If we look at the P1 value of each, we can see that they are all belonging to file 5. For these wait events, P1 is the file number. In the case of the GCCR multi-block read request, the trace file actually shows us the file number instead of saying P1. The P2 parameter is the block number. And again, these are the same blocks, 515, 519, and 131. Which objects do these blocks belong to? I'm going to cut and paste in a simple SQL statement. Let me reformat that so it's a little bit more readable. We can see from this query the results that were returned is that file 5 starting at block 128 for a length of 8 blocks is the DB objects table. This contains block 131. So that final event was for block 131 from the DB objects table. File 5, block ID 512 for 8 blocks is the index. And this shows us that we use the index. So now let's go back to that trace file. Here's that trace file where we left off. The first global cache wait event is saying I need to read some data from the index. The second one is getting more data from the index. The third wait event for the global cache transfer is getting the block of data from the table itself. Now, the astute person may have noticed that there's a slight difference here. If we go back to host 01, notice that the first read event of interest here is block 515, file 5, just like the first global cache transfer. But notice that the second one is block 516 of file 5, but 4 blocks were read. So this is blocks 5, 16, 17, 18, and 19. Yet when the data was transferred across the wire on the second global cache transfer, file 5, only block 519 was transferred, not all 4 blocks that were read in that physical read. So this is even more efficient. And then in the end, no matter which session we were looking at, block 131 of file 5 was read to get the data. So we can see here that global cache transfers via Cache Fusion are working as advertised. The data was read from disk on a session in instance 1 and then transferred via the Cache Fusion mechanism to instance 2.